front of this postulate sheet, we have covered each of these theorems so far. Linear pair postulate we covered in section 3.1. It's on page 4 of your notes packet. Says that if two angles form a linear pair, then they are supplementary. So that linear pair postulate, when we come upon the proofs, the linear pair postulate is one of the ones that comes from a picture, from a diagram. And you see a picture like this to get that information. And it says they are supplementary. So when we come across the proofs, if we see a picture that looks like that, if we see a linear pair in the proof, we're able to say that they are supplementary angles. Now, if we see a pair of vertical angles, now vertical angles are the ones that make that X, but I've got 4 angles marked in this picture. Not all 4 of them are vertical angles. Well, at least not to each other. Angle 1 is vertical to what angle? Angle 2. They have to be across from one another. Vertical angle theorem says that they are congruent. But technically 3 and 4 are also vertical angles, and therefore are also a pair of congruent angles. That's also one that comes from a picture. Now, the next section of our postulate sheet specifically says, given parallel lines and a diagram. This one requires multiple things. Symbol for parallel lines, what's it look like? On the picture, it looks like the little triangles. So like these are parallel symbols. Otherwise, it looks like that. It looks like a pair of parallel lines. Corresponding angles. Are corresponding angles congruent or supplementary? These ones are congruent. Corresponding angles. Are they on the same side of the transversal or opposite? Opposite starts with alternative. Does that start with alternate? Nope. So they're on the same side of the transversal with corresponding. Interior, exterior, or one of each. Here's the hint. Does it say interior or exterior? No, which means it has to be one of each. The corresponding angles could be angle 1, which is congruent to angle, which one corresponds with 1? Has to be on the same side of the transversal, which means 2, 4, 6, and 8 are out. Can it be right next to it sharing a vertex? Can't be right next to it sharing a vertex. Is one an interior or an exterior angle? Exterior, which means the other one needs to be interior. 5. Angle 1 is congruent to angle 5. Or angle 2 is congruent to angle 6. Or angle 3 would be congruent to angle 7. Or the last pair of corresponding angles in this one is angle 4 is congruent to angle 8. If we were doing proofs today, we're not actually getting to the proofs yet. If we saw a parallel symbol,
I can't see it.
if we saw a parallel symbol, we would be looking at one of these, and we'd be looking at the picture to determine which kind of angle pair it is. If it was corresponding angles, we would mark them as congruent. What if it's alternate interior angles? Are alternate interior angles also a congruent one? Yes, alternate interior angles are also a congruent pair. Alternate means where compared to the transversal? Same side or opposite side of it? Opposite. Alternate means opposite sides of the transversal. Interior tells us it's inside of the two lines being crossed. So inside the lines being crossed is 3, 4, 5, and 6. Let's say I started with angle 3. We already established it would be congruent. Angle 3 is congruent to angle 6 by alternate interior angle theorem. Or the other pair of alternate interior angles, 4 and 5. Alternate exterior angles. Alternate means opposite sides of the transversal. Exterior means outside of the two lines being crossed. Two lines being crossed are here. Outside of it is 1, 2, 7, and 8. Are alternate exteriors congruent or supplementary? This is also a congruent pair. Angle 1 is congruent to angle 8 is its alternate exterior. This is on the opposite side of the transversal and outside. Otherwise, its angle 2 is congruent to angle 7. The last angle pairing that we have is our consecutive interior angles. Interior means between. Consecutive is not the word alternates, are on the same side of the transversal. Are consecutive interior angles congruent or supplementary? Oh, I got both congruent and supplementary being told to me. If only we had notes that had it written down on like a page 6 or something. Supplementary. Angle 3 and angle 5 are supplementary. Or angle 4 and angle 6 are supplementary. If we come across a proof that is talking about those angles, we would say they are supplementary by the consecutive interior angle theorem. Ooh, before we move off of this, I just realized I didn't give the shortened versions. How do I shorten consecutive interior angle theorem? CIA just tells me the angle type. I also need the THM to tell me you're using the theorem. Because the theorem tells me that it's applying to parallel lines. If you don't tell me you're using the theorem, you're just telling me it's an angle pair. Alternate exterior angle theorem. AEA. THM for the theorem. Alternate interior angle theorem. AIA. THM for theorem. And corresponding angles postulate. CA and post. This is what we've talked about so far this unit, is we talked about these angle pairs. So, open up to page 8 in your notes packet. When it comes to this chapter, being able to recognize these angle pairs and knowing if they're congruent, if they're supplementary, or if there's something else is the key thing for this entire chapter. If we don't get that down, we've got issues. And here's the thing, I've noticed there's maybe like 3 of you answering all my questions. I need more than 3 people answering my questions. So I got name cards. So, it says identify the angle relationship and solve for the variable. One of the things that I am going to do is a quick reminder. If you are trying to solve these, if you struggle with identifying the angle pair, especially the new angle pair, you can always orientate this picture to be kind of in the same realm. My transversal is kind of going up and down-ish. It's like here. That angle and that angle are in the same spot as angles 3 and 5. And if I recognize that it's in the same spot as angles 3 and 5, that can help me identify which of these pairs has 3 and 5 together? CIA. So if you are struggling with that, use that postulate sheet to help you. Now, CIA theorem only works if lines are parallel. Do I have parallel lines in this picture?
Yes.
Sweet. So I can use the CIA angles. It says identify the relationship. It doesn't say I have to tell what theorem. If you write CIA theorem, I'm not going to hold it against you as long as lines are parallel. Okay. According to this, CIA, angle 3 and 5 would be supplementary. Ella, what does supplementary actually mean?
Great question.
It's on the first page of your house. Very bottom of the first page.
They make them sum
They sum
up 180.
up to 180, meaning they add up to 180. (31x minus 4 plus 14x plus 4 equals 180. You should grab a calculator if you don't have one. Otherwise, I might be quizzing you on all the calculator things. Just the person who doesn't have the calculators.
Yeah.
So, 31x minus 4 plus 14x plus 4 is equal to 180 is what I've got. Lily, if I want to solve this, what would you tell me to do first?
So I would subtract 14.
Oh, but they're on the same side, so don't subtract it. Add it. We're combining like terms. 31x and 14x is 45x. What's a negative 4 plus 4?
0.
0. Equals 180. Divide by 45 and x is 4. Now, question for you. Did we answer everything the question asked for?
Yes.
Yes. Make sure you're checking that, and then you can move on.
Wait, do we have to circle?
You don't have to circle it. No, I just circle it to indicate what the answer is. The next one looks a little different. Here's the first thing I noticed about the next one. My two angles, right here and right here, they share a vertex. If they share a vertex, they are not corresponding alternate interior, alternate exterior, or consecutive interior angles. It's none of those four. Are these vertical angles? No. Are they a linear pair? No. A linear pair says they share a middle line. These two do. But it also says that the two lines they don't share create a straight line. Jerry, what are they? Adjacent. Adjacent angles isn't on our postulate sheet because adjacent angles is something we did all the way back in chapter 1. We did it in chapter 1, we did it in chapter 2. Adjacent angles do not have a specific theorem to them either. Adjacent angles can simply be added to make the big angle. Little angle's 36. Other little angle is 5x plus 4. Why 90? It has that little box. Jocelyn, if I want to solve this, how do I start? Combine my like terms. 36 and 4 is 40. Do I get rid of the 5 or the 40 next? 40. I subtract the 40. 5x is equal to 50, and then x is 10. So adjacent angles can still come up. They're a bit of an oddball out, but they can still show up. Question 3. My angles do not share a vertex, so they're not vertical, they're not a linear pair. I've got 4 lines going on. Is one of these lines there to not helpful? Or more accurately, which line is not helpful?
Second one.
Which one's the second one?
One that's going this way.
You're the 1, 2, 3, 4 thing.
1, 2, 3, 4. Don't let an extra line throw you off. Okay. So, I ignore that line. That line is there to throw me off. If I pay too much attention to it, I'm going to have issues. I can't call on someone who wasn't here the last 2 days. That's just mean. Nick! What kind of... Yay. I guess I can call on someone who wasn't here the last 2 days. I was going to call on you for a different type of problem. A. Okay. Are alternate exterior angles congruent or supplementary? Look at your yellow sheet. They are congruent. What does congruent mean, Kate? They are equal. 41x minus 2 is equal to 39x plus 2. Noah, how should I start solving this? Make sure we get those x's together. When they're on opposite sides, we do opposite operations. 2x minus 2 is equal to 2. A common mistake I see at this point is people thinking these 2's are going to cancel out. But to move this 2 over there, I'm not subtracting it, I'm adding it. Be careful of that. 2x is equal to 4, therefore x is equal to 2. This problem has a lot of 2's. Okay. Question 4. My 2 angles are not sharing a vertex, therefore it's one of those 4 most likely, assuming I've got parallel lines, and I do. Mohammed, what kind of angle pairing are these 2? They are corresponding angles. CA, beautiful. Trevor, if they are corresponding angles, they equal each other. So 131 equals 4x minus 3, or plus 3. 128 equals 4x, divide by 4. X is equal to 32.
Yeah.
If I was doing a proof, could I have gone directly from 128 equals 4x to x equals 32? No, I would have done this first. How do I get from 32 equals x to x equals 32? Symmetric property. Question 5. Take a look at those angles. Are there lines here throwing us off?
Yeah.
Okay. 1, 2, 3, 4. 4. And 3 isn't being used either. The angles aren't touching that side or that line at all. Both of them are there to throw you off. Do you notice that the two angles share their vertex? Which means it is not one of the 4. It is either adjacent, a linear pair, or vertical angles. And they look like that. Are they making the line, or are they crossing one another on an X? They're making the line. They're a linear pair. For some reason, the moment I give you parallel lines, people tend to assume that it has to be the parallels. It doesn't have to be. Okay. Are linear pairs supplementary or congruent? Look at the yellow shade. Supplementary, meaning they add up to 180. 9x plus 14 plus the 9x plus 4 equals 180. I combine like terms first. I've got a 9x and a 9x on the same side. I get 18x. I got a 14 and a 4. It gives me an 18. What's that step called in a proof? Simplify or simp. Here, generally we can pick up and we have no problem. Subtract the 18, I get 162. Divide by 18 and x is equal to 9. Can you put the laptop away, please? Okay, question 6. I'll catch you up on the other part. Follow along with what we're doing now. Okay. Problem 6. Do you see parallel lines? There's no parallel lines in this picture, which means it is not CA, CIA, AEA, AIA. Are they a linear pair? No, they're not creating a straight line. Are they vertical angles? No, there's no X that they are across from, which means adjacent, because they're next to one another. Now, adjacent angles, do they have a specific thing that they add up to? It's just little plus little equals big. I'm given 39x, I'm given 20, and I'm given 29x. Which one's the big angle? The 39x. Is it because it's first? Is it because 39 is the biggest? Or is there another reason? Because the biggest angle is angle TSR. So be careful of that. That's one of the things that I've commonly seen mistakes happening on, is people adding up the wrong angles. TSR is the big one, which means the two I'm adding are the 20 and the 29x to equal the 39x. Subtract 29x. 20 equals 10x, and divide by 10. X is equal to 2. Or in a proof, I would write 2 equals x, and then flip it around. Is this a proof right now? No. Am I upset if you flip it around right away? No. I'm talking about the proof stuff because proofs are coming back, and I would rather you not get completely rusty on the proof stuff before the proofs come back. We got 2 more. Question 7, do you see a pair of parallel lines? No, which means not CA, not CIA, not AEA, not AIA. Eli, what kind of angle pairing do these look like? Do you see an X kind of forming? Are they across from one another? Which one is that? You got it. Kelby, if they're vertical angles, what's my equation gonna look like? So what would I write then?
2 plus 4x equals 86.
You got it. Since x is only one place, I'll move the numbers first. 4x equals 84. Divide by 4, and x is equal to 21. That final problem. Do you see parallels? No. Not seeing parallels rules out what kind of angles? CA, AIA, AEA, CIA. They are all out. It has to be linear pair, adjacent, or vertical. Vivian, what kind of angle pair do you think this one is? You fell for my trick. I'm sorry. It is not VA because you kind of see in the X, right? But they're not across from one another on it, and it's not a perfect X. This one was meant to trick you. Whoa, I clicked the wrong button. There we go. For it to be vertical angles, that has to make a perfect X. This is fine, but that one kind of goes a little wonky if it goes here and here.
I think you dropped something.
So, this one was meant to be a bit of a trick. This right here is not helpful. It's not being used. It's there to throw you off. And the moment you get rid of it, if you ignore it, now what does it look like? Linear pair. Jesus? If it's a linear pair, what's the equation going to look like? You got it. Combine our like terms. 3x and x is 4x. A 1 and a negative 9 is a negative 8. And we solve. Assuming I could do my math correctly. Beautiful, because I did do it in my head, and that's not always a good thing. Anything we're doing today any different than what we've done? No, because this is the most important thing on this chapter. What's happening tomorrow? Quiz. Tomorrow there is a quiz. There is also a lesson tomorrow. Tomorrow's quiz is a shorter quiz, and it's one that should go quicker. Because, have you noticed, for the most part, do these questions take a whole lot of time? They're slower when we go through them together, but when you go through them individually, they tend to go pretty quick.